All right, now just quickly, the reason why I gave you these triangles when doing this is because these triangles, which we actually get from the unit circle, and also I started with a triangle, and I've been through this with you before, but I started with a triangle that was 2 and 2 and 2. Okay, now from that triangle, what did we do? Each of these angles was 60 degrees. And what did we do, Sophie? We cut it in half. Good. And then that half becomes, we now have this triangle here. 2 becomes 1. This side is not changed. This side, this angle is not changed. 60 degrees is now 30 degrees. And we had to work out that this angle, or this length, was root 3 from Pythag, because 2 squared is equal to 1 squared plus the square root 3 squared. So that's where we got the square root of 3. So we've got one triangle. We've got this one here. Well, if I've got 245, this is an isosceles triangle, 2 sides the same, then this is a length of 1. So what is 1 squared plus 1 squared is 2. Yeah? So what's this one? Is it 2 or root 2? It's root 2. Okay, now, so I wanted you to finish that off. Now, what we're going to do is we're going to find sine, cos and tan of 30, 45 and 60 degrees from these triangles. So sine of 30 degrees is opposite over hypotenuse. So that's 1 over 2. Sine of 45 and cos of 45 are both the same. 1 over root 2. And I can also tell you that cos of 45 is 1 over root 2. And sine of 60 is opposite over adjacent. So root 3 over 2. And as it turns out, like 30 degrees and 30 degrees for cos is what sine is at 60 degrees. So, but we could have used the triangles. And so far we've got this. Now tan is one of two things. It's sine over cos. It's actually the tangent, or we can just use the triangles. 1 over root 3. Tan of 30 degrees, if I was to go here, tan of 30 degrees is opposite over adjacent. So the tan of 30 degrees is 1 over the root 3. Tan of 30 degrees, 45 degrees is just 1 over 1, and this is root 3 over 1, or just root 3. Now, quite a few of you asked me, what is sine, cos and tan at 0 and 90 degrees? Well, what did I say about, what was the x-axis? The x-axis, what does it say here? The x-coordinate is what? Let's have a look over here. What's the x-coordinate? What's this x-coordinate? Cos theta. So what I want you to do is picture the unit circle, and the x-coordinate is cos of theta. And the y-coordinate is sine of theta. Now, if I've got the x-coordinate and the y-coordinate, can you tell me then, given that 0 degrees is here and 90 degrees is here, what is the x-coordinate of cos of 0, Matt? What's this x-coordinate here? It's a unit circle. So what's this distance here, Matthew? It's the unit circle. What does a unit mean? 1. Okay, pay attention. All right? I don't want the excuse I haven't been here. A unit is 1. Cos of 0 is 1. So cos of 0 is 1. Now what's the y-coordinate? Given that sine of theta is the y-coordinate. What's the y-coordinate of sine of 0? What's the y-coordinate here? It's 0. Yeah? What's the height? In other words, what's the height here? At this point here? The height's 0, isn't it? Now, as it turns out, that tan is sine over cos. Tan is sine theta over cos theta. Okay? It's the gradient of the tangent to the point. 0 over 1 is 0. Okay? Now, what about if I'm dividing something by 0? Over here, we've got sine of 90 is 1 because the height is 1, and cos of 90 is 0 because what's the x-coordinate here? What's the x-coordinate here? 0. So cos of 90 is 0. What's 1 divided by 0? Undefined, thank you. Very good. Now, the thing is, you can bring your bound reference in to this test. Can you, however, this is the important thing, you cannot bring your bound reference into exam 1 because exam 1 is a no calculator, no notes. Okay? So you don't need to memorise this for your test. However, this table, I want you to be able to get one way or another. Whether you do it my method, whether you've got your two triangles, or you simply remember that these things are the same. Okay, I just really need to swap these over. Sine of 30 is cos of 60, and so on. So you really only have to remember these values are both the same. You can also think about sine on cos is tan. Or I prefer to get the triangles. You could, as soon as you walk into that test, you can draw your triangles and you can draw this table out. Okay? You're not given the table in exam 1. Aidan, do you have a question?
Just about the first exam, how long will that be?
First exam, 60 minutes.
For the next questions, I can find the exact moment.
Yes, that's what we're doing now.
Oh.
All right, now, this is the last thing I'll say. And Patrick, do you have a question?
Yeah, just the first exam, does that tend to be easier than the one with the calculator?
No, not necessarily. The first exam is more based on skills. Second exam is on the applications.
Okay.
The calculator one is CAD.
Yes, it's a CAS. Now, can I just get back to this because we are still recording, and we'll be on YouTube as asking questions. I can answer those questions in a moment, or I can just pause if you've got some big ones. All right. Now, what we're going to do now is that we've got to consider that we've got the unit circle, and what did I say about the unit circle? Now, we had a little mnemonic to remember it, and there's all sorts of things to remember what it actually means. But what does A, S, T, and C mean? All. So they're all positive in this quadrant. In other words, sine, cos, and tan. That's why what we do is we have a reference angle in the first quadrant. Let's just say if I have this value over here, let's just say this value over here, I've got my unit circle. Okay, I've got my unit circle. If I've got a value over here, I find a reference angle in the first quadrant. And what we can do is we can map that out in the second, third, and fourth quadrants to the horizontal. Okay, and that's a really bad looking circle. Okay, now, it's a shocking circle. But what can you tell me? What can you tell me about the x-coordinate here? Let's just say the x-coordinate here was 0.8. What can you tell me about the x-coordinate there with the same reference angle in the second quadrant? It's 0.8, but it's negative 0.8. Okay, we're talking about the... But what about the height? Let's just say if my value of sine theta was 0.9, what would be my height over here? It's also 0.9. Okay, because you see there that they're both positive values of y, but what's happening to the x value? We've got a positive value over here, and that's why sine theta is positive in the second quadrant. Because what is sine theta? Sine theta's so sine is the only thing that's positive. In the third quadrant, tan is positive because what can you tell me about if I had a value here? And sine, we know that this is, let's just say this is negative 0.6, negative 0.8. What can you tell me about sine theta or cos theta and sine theta? They're both negative. So tan theta is sine on cos. So a negative 0.8 over 0.6 negative is going to be positive. So tan is positive in this quadrant. And then, of course, cos is positive because the x values are positive in this quadrant. That's really all I want you to get out of this, is that you need to recognise what is positive and negative in each quadrant. And then we'll certainly ask you something like that in your assessment, short assessment. And the next thing is finding some exact values. So let's map out sine of 120 degrees. 120 degrees, we've got to go across here 90 and we've got to go across here 30 degrees more. Do we care about the angle from the vertical though? Don't we care about this angle here?
60.
That angle is 60 degrees. So what we can say is that sine of 120 degrees is the same as sine of 60 degrees, and is sine of 60 is positive, is sine of 120 also positive? Yes, it is. So the answer is sine of 60, which is equal to root 3 on 2. So we fill that out, root 3 over 2. Now, let's go ahead and do cos of 120 degrees. Now, cos of 120 degrees is a little bit different. It's still the same angle, but cos of 120 degrees is this time we've got to go... It's the same reference angle. This is the reference angle of 60 degrees. So we have a reference angle of 60 degrees. And that reference angle in the first quadrant is what we're after. But the question is, cos of 120 is actually the negative of cos of what? Of our reference angle, which is 60 degrees. And it's a negative because what's cos in this second quadrant? Negative. Okay, so cos of 60 degrees is a half, so it's negative a half. Now, what about tan of 150 degrees? This time, we've got to go around anti-clockwise 150 degrees. We go around to 150 degrees. This is 150 degrees. If that's 150 degrees, what's my reference angle to the horizontal? 30 degrees. Now, if I've got 30 degrees here, then, now be careful, is tan positive or negative in a second? Only sine's positive, so it's negative. So tan of 150 is equal to the negative of tan in the first quadrant, which is our reference angle. Negative tan of 30 degrees is equal to negative 1 on root 3. Now, what about sine of 240? What's my reference angle? I'm going to pause this video, and I'm going to get you to have a go at the last 4, and I am going to pause it, and we're going to go through them together. So can you have a go at the last 4, and then we're going to go through them together. I'm going to resume now, and sine of 240 degrees. Well, first of all, the first step is, I'm going to go over this once more. The first step is draw the angle. Draw the angle and find the quadrant. Find the quadrant. So I'm going to do that. 240 degrees. We're going to go around 180 degrees, and then we're going to go another 60 degrees. So what is my reference angle? My reference angle is 60 degrees. Now, you always need to find that reference angle. Then you have to ask yourself, step 2, is sine of 240, is it positive or negative? Positive or negative? What is it? It's negative. Okay, so we've now identified that it's in the third quadrant, that sine is negative. We've found the reference angle. So therefore, the reference angle, that's why we do this, because we track it back to the first quadrant, and we can say that sine of 240 degrees is equal to the negative sine of 60 degrees, which is equal to negative root 3 on 2. Sine of 60 degrees is root 3 on 2. But because it's in the third quadrant, it's negative root 3 on 2. So, step 1 is we find the reference angle. and we find what quadrant we're in. This is step 1.
So wasn't the representative? Yeah, I didn't get why you started at 60.
No, 60 degrees. We've got to go 180. It's to the horizontal. The reference angle's never to the vertical. You've got 30 degrees there. The reference angle is to the horizontal. That is 60 degrees. 180 plus 60 is 240.
Why is it, I didn't get why the reference angle was 60. I thought you said
All right,
around-
just
Yeah, 'cause
because it's to the horizontal. We'll go through it again. This time, tan of negative 150. Tan of negative 150. We're going, rather than going this way, we're going this way. We're going clockwise
why are we going clockwise?
because it's negative.
So you have to do the opposite.
This way is positive. Going this way is negative. Okay, so we're going clockwise 150 degrees means that this angle here is 150 degrees, but the angle to the horizontal here in this quadrant is 30 degrees. Is tan positive in that quadrant?
Yeah.
Yes, it is, because so it's the same as tan of 30 degrees, which is equal to 1 over root 3. Cos of 270. Well, cos is the x value. 270 degrees is going to put me right there. What's the x coordinate right there? 0. Cos of 270 is 0. And sine of 225. First of all, sine of 225, we've got to go around. We've got to go around. And we're going to have it here. I'm going to draw it over here. We're going to go around, and my angle here, my reference angle to the horizontal is 45 degrees.
It's negative.
That's correct. So, sine of 225 is equal to negative sine of 45 degrees, which is minus 1 on root 2.
I actually got it.
Good. Can I get a show of hands, those students that are starting to get this stuff now? Now, if you don't, good, then I'd suggest you watch this video again, which is 17 minutes worth, because it will take some of you longer than others to get this concept. I'm going to stop there.